Okay, so let's continue with this problem. Now what I want to do is find the acceleration, or the angular acceleration. So I'm going to do the acceleration one. In order to do the accelerations, you will usually need the angular velocities. So even if you are not being asked to find the velocity, you probably should start by finding velocities because you need the angular velocities. Also, once you do the velocity equations, it's much easier to get the accelerations. It makes more sense. I refer to it as emulating the velocity equation. So what I've done here to start this off is I've written the velocity solutions, the equations, and the angular velocities that I found from the previous one. And we're going to basically start here. What you'll find typically is that your acceleration equations are going to mimic the velocities. So let's start with the first equation. I'm going to write an acceleration equation that's similar to the velocity. If you notice, I wrote it between c and d, and so I'm going to do the same thing down here. I'm going to write the acceleration equation in terms of between c and d. So here we go. The acceleration of c is equal to the acceleration of d plus, now the acceleration equation has angular acceleration, not angular velocity. So instead of omega 2, I'm going to have the angular acceleration, which is usually called alpha. Alpha of 2 cross, it's the same r that it was before. And then you have these other terms, and if it's two-dimensional, these long terms end up being omega of body 2, r from d to c. And then there's a whole bunch of rel terms, and they're all zero if the 2 points that you're considering, D and C, are always a fixed distance apart, which they are, and so all of the rel terms are zero. Okay, now what we'll do is we'll mimic the second equation. So when you mimic the second equation, you'll have acceleration of C equals acceleration of B plus alpha, it's body 1, so this would be alpha 1, cross B to C, or B to C, minus omega 1, oop, there's a square, omega squared, R, B to C, and all the rel terms are zero again for the same reason. Okay. So now, because these guys are simple angular velocities, the alpha of body, let's see, we numbered this one 1 last time, and this was body number 2. So the alpha of body 2, because it's simple angular velocity, is the second derivative of an angle. So that would, the angle would be theta double dot, and then k is okay, the positive direction was counterclockwise, if you remember. And so now if theta is getting bigger, this would be in the counterclockwise direction. So this guy should have a positive theta double dot k. Over here, the alpha of body 1 should equal, since it's simple, it will be theta double dot as well, and then get the direction. So if theta over here is increasing, the body 1 is going clockwise, and clockwise happens to be a negative direction, so that would be a negative k. Essentially, this is plus and minus signs, just like in the velocities. So anyway, let's put numbers in over here. So for the acceleration of c, what you know about c is nothing, and so this would be the acceleration of c equals acceleration of d. Well, if you look up at d, this point right here, just like in the velocity, this is permanent contact with the ground. So the table says that the acceleration of d is equal to the acceleration of the ground. Ground's not doing anything, so that's a 0. plus the alpha of 2. The alpha of 2 is theta double dot k, cross the r, just like it was before, from D to C. Probably should have written them down from before because they're exactly the same. So from D to C, this is going to be a negative 0.3 cosine of theta I, and it's going to be a negative 0.3 sine theta in the j, exactly what it was before. Okay, and then you have this other term, minus omega squared, so that'll be minus the omega of body 2, and we solved for it before. That's this term right here. So I'm going to square that guy. So the negative sign, when you square it, comes out positive. V squared over 0.6 sine theta. I guess I ought to write it like this, all of that mess squared, times the r, and the r is going to be a negative 0.3 cosine theta I minus 0.3 sine theta j. Okay, now let's get the blue equation. Okay, acceleration of C, again I don't know anything about it, equals acceleration of B is in contact with this unrotating body, so all points in AB have the same velocity and acceleration because it's not rotating. Therefore the acceleration of B is little a to the right. And then I have an alpha 1. Alpha 1 is minus theta double dot minus theta double dot k, cross the r is exactly what it was before. It's going to be 0.3. I remember what it was, so I'm just going to write it in here. Minus 0.3. It's exactly what it was before. You don't have to even think about it. And then you have these extra terms over here, minus omega squared of 1. That's going to be v over 0.6 sine theta squared times the r, 0.3 cosine theta minus 0.3 sine theta. Okay. Now the next thing you're going to have to do is the cross products. So let me just do the cross products over here. I'll put them in a different color. Okay, so I'm going to take these cross products. Right. So just like before, it's going to be theta double dot minus 0.3 cosine of theta. K cross I is a positive j. And then I have a negative theta double dot 0.3 sine theta. K cross j is a negative I. So I have that. Okay, and then this cross product, the blue cross product, that term is, bring all the constants out front, minus theta double dot 0.3 cosine theta. K cross I is a positive j, and then I have a negative is positive, theta double dot 0.3 sine theta. K cross j is a negative I. Okay, now now that I've done the cross products, we're going to gather up all of the i's and j's and everything else. So because the first equation, that's AC and AC, then the right hand sides are equal. So I'm just going to do the right hand sides. Okay, so here we go. The red part is the cross product. That is a negative. That is a negative. The cross product would be theta double dot 0.3 cosine theta j minus theta double dot 0.3 sine theta I. That's the cross product. And then I have this other stuff, minus v over 0.6 cosine of theta squared times a negative 0.3 cosine theta I minus 0.3 sine theta j. So that's the red equation, and that equals blue equation. So let's see, that's an AI. The cross product is minus theta double dot times 0.3 cosine theta j minus theta double dot 0.3 sine theta I. Then I have all of his extra terms, all these blue things over here, minus v over 0.6 sine theta squared 0.3 cosine theta minus 0.3 sine theta j. Okay. Now, just like before, you extract equations by setting the i's on the left equal to the i's on the right, j's on the left equal j's on the right. So let's do the i's. I'll put them in red. On the left-hand side, you have a negative 0.3 sine theta, theta double dot. Let's see, you also have another positive v over 0.6 sine theta squared times 0.3 cosine theta. That's all the i's on the left. On the right hand side, you have an a minus 0.3 sine theta, theta double dot, and a minus v over 0.6 sine theta squared times 0.3 cosine of theta. Now, the j is equal to the j, so on the left-hand side, you have a negative 0.3 cosine theta, theta double dot. You also have another positive, let's see, v over 0.6 sine theta squared times, let's see, that would be 0.3 sine theta. On the right-hand side, the blue stuff, you have, let's see, j's, a negative 0.3 cosine theta, theta double dot, j's, here's another j, so minus minus, you have a plus, v over 0.6 sine theta squared times 0.3 sine theta. Okay, so there's my equations, two equations. One of them is here, and the other one this one. So what I solved for last time was theta double dot, so that's what I'm going to do again this one. Now, just like before, if you look at the second equation, the left-hand side is exactly the same thing as the right-hand side. So when you subtract it, or you solve it rather, you're going to get 0 equals 0. It's true, it'll always be true, but it doesn't do you much good. So I'm going to solve the top equation. And so the top equation, and I'm solving for theta double dot, so I'm going to gather up all the terms. So I have, let's see, the theta double dots I'm going to gather up on the right hand side, so that would be a negative 0.6 sine of theta double dot, and then everything else I'm going to shove over to the right hand side, so that equals a minus v over 0.6 sine of theta squared times 0.3 cosine of theta. And I have another one of those guys, so I'll bring it over, so there's going to be another one just like him, so there's two of those guys. And that's it. So solve for theta double dot. Theta double dot equals a minus 0.6 cosine of theta times v over 0.6 sine of theta squared divided by a negative 0.6 sine theta. Okay, so there's your theta double dot. So that's it.